Okay, welcome to AP Stats. This is review day. We turned in homework 9.3. This is Winna's solution. I just want to let you know what I was looking for full credit was natural log weight of the alligator. You got to have the hat there. And hopefully this is in focus. But yeah, all you had to do was have the slope, the intercept, and length. For part B, all you had to do was exponentiate by raising e to that power. So it came out to 77.416. And then for part C, the interpretation, you could say for each increase of 1, or since there's no log there, you could just say for each additional inch in length, the model predicts an increase of that slope in natural logarithm of weight of alligator. You don't say feet, you don't have units there. It's kind of a clunky expression there. So you can take a screenshot of that if you want to study it. That was the homework. Now we're going to the test. Ladies and gentlemen, you have an opportunity to ask any questions you want on the practice test for tomorrow's test. So what would you like to ask about either the multiple choice or the free response for the test? Who'd like to go first? Okay, Sam, go ahead.
Question 9C.
All right, so we're looking at 9C. Again, the solutions are online for this. Now, by the way, last period they asked about 9A because there's like 3 interpretations. There's the, assuming the scatter plot is straight enough, it's a moderate negative association. That's kind of like a bottom shelf interpretation. A middle shelf is to be able to condense that down into, well, this means the more miles you drive, the lower the asking price. You put so many miles on your car, you can't ask that much for it. But we want a top shelf interpretation because this is really the deepest understanding. But you're asking about part C?
Yes.
Is that true? Okay, so part C.
I'm just wondering why do you circle that one instead of the one that is closer to 10,000?
Okay. So I need to figure out, first of all, on a residual plot, they have 2 options for the horizontal axis. They can put either the miles on the horizontal axis or predicted price. And so you have to read the label on the horizontal axis to find out which one they're using, because it doesn't matter. They can form a residual plot with either the x variable or the y variable on the horizontal axis. They chose to use the y variable, the predicted value. So that's why you have to go to the answer to part B, which they predicted 10,707. Then you have to go here to find the residual. You have to find 10,007, so about 10.7 thousand. This is 11,000. This would be 10.2 thousand approximately. We came up with 10.7 thousand, so this is the only residual that could possibly match 10.7 thousand. Okay, because you're reading the units here, 10,000, 11,000, so 10.7 would be right about here, which means that's our residual. And it looks like our residual then is about 1,000. That's an estimated residual. Okay, does that answer your question? Now notice that issue of reading the axis on the residual plot, that came up on another one of these problems. Take a look at problem 11A. In fact, this problem is designed to punish students who don't pay attention to detail. Because if this axis on the residual plot, if this had said time instead of predicted concentration, then what most students do is they say, okay, they put 3.5 in and they just go along until they get to 3.5. Ignoring the fact that this is not the time axis, this is the predicted concentration axis, because 3.5 would have a positive residual. So that would lead to a different answer if you have to go until you get to the predicted concentration, which is 19.46. Well, 19.46 is right about here where you get a negative residual. This whole problem hinges on whether the residual is positive or negative. So watch out for reading the labels on the residual plot axes. Okay, so Sam, have I answered your question then to your satisfaction? Are you okay with the one that you asked about?
Well,
Because I'd be happy to go back to that. You were asking about 9C.
Yes, I'm still being confused.
You say you're still confused?
Yeah, because the predicted value is closer to 10,000, right?
No, it's closer to 11,000. 10,700 is closest to 11,000.
Oh, right. Okay, I see.
Okay?
Yeah, I see. Okay, I got it.
Further questions on the practice test? All right, Val, go ahead.
Just like throughout the free response, like it'll ask you to solve for something. So I'll just put like the value and then the hat and then equals and then like use a unit, but you always put like a sentence. Do you really need a sentence?
Right, you need to be prepared to express your answers in sentence form. I know that's a bit of a stretch. It's one of the hardest parts of this course is it's a writing course. But if you're in a multiple choice situation and the answer is expressed in sentence form, you need to be able to be accustomed to that. And especially, like for example, in part A, it says explain, so you're obligated to express yourself in sentence form. And if it doesn't, and there are some times where it just says calculate. So if they're asking you to calculate something, then you don't have to write the answer in sentence form. But otherwise, it's best to err to the side of verbal expression. Further questions on the practice test? All right.
Number 6.
All right, let's take a peek at number 6. So, number 6 is a when in doubt, draw, well, no, actually, you're fine with this. It's a two-step problem. They held back on B0. They gave you B1 is 3, but B0 is not disclosed, but they gave you a point that's on the line of best fit, so you can put a 2 in for X, a 5 in for Y hat, and solve for B is -1. So once you find B is -1, then you can answer the question about finding Y hat when X hat is 7. Just replace X with X, finding Y bar when X bar is 7. Just replace X bar with 7 because, this problem is basically checking to see, do you know that the point X bar, Y bar is always on the line of best fit, also called the least squares regression line? That's what they're checking for. And by the way, this is sometimes when people are tired, they say, let's take a bacon break. We're gonna take a linear regression break. And I've got a website, this is one of my favorite websites. Check this out. You're gonna get a chance to come to the board. One of you will be randomly selected to come to the board for this. So whatever you're doing, take a pause, just press pause on that and check this out. Got some points. And look at what happens when, Katie, come on up. I'd like you to come up to the screen. And then pay close attention to what Katie does, because you might be next. Would you, at this website, please click in the box for show least squares line. Notice it automatically puts in a line of best fit. So, Sherry, go ahead and watch what Katie's doing. What do you think is going to happen when she clicks the show mean X and Y lines? Go ahead and click that box. Sure enough, X bar, Y bar is on the point. Now, I'd like you to take this point right here and just move it straight up and down. Class, how much leverage does this point? Just take that point, grab it, and just move it straight up and down. Notice it's changing the correlation coefficient and go all the way down to the bottom. What is moving that point doing to the slope of the line of best fit? Is it influencing the slope of the line of best fit or not? Go ahead and move that some more. It's changing the y-intercept, it's not changing the slope. Now let's give it some leverage. Take this point and pull it out to a high level because there it has no leverage. Look at how much influence it has when you give it leverage. Now here's my challenge to you, Katie. In fact, go ahead and move this point up and down, just grab it. Look at how much influence it has. Influence is judged by how much the presence or the absence of the point changes the slope of the line of best fit. Now, notice that when it's down here, it's pretty close to the original slope. Go ahead and move it up there. It's like it has this vertical magnetic pull. When it has high leverage, it has the leverage to pull. So go ahead and take this point, move it back to where it was. Okay, see if you can move this point from here to there in such a way that the slope of the line never changes. Move it from one place to another. Oh, look at that, that's pretty good. And, oh, now it's changing a little bit. See if you can get it down to here without ever changing the slope of the line. She did it. Notice how those are all, thank you, Katie. Let's give Katie a hand. She came up and that's actually not easy to do. Students who came up last period got it eventually, but look, she found the path because she basically had to find all the points that have no influence. Because all of these points do not change the slope of the line of best fit. And then all of these points do not change the slope of the line of best fit. So she found an infinite number of zero influence points, and that became her path. Now, however, notice over here, there's a lot of influence. I can click show residuals, and so now you can visualize what's going on. It's like a point that has leverage can speak to the line and say, come to me, come closer, follow me down here, and it follows. But notice that when the point's over here, it's like low leverage means no one's listening to it. It's like, come and follow me up here. No, never mind. You go there, but I'm going to stay here. So points with low leverage, kind of like on the practice test back on, I think, page one, question 1. This point, if you visualize line of best fit, then X bar, the X bar line, then take that over the Y bar line. You can see, you can visualize that this point P has very little leverage. It has a fairly large residual. Low leverage, it's not influential because of the low leverage, and it will have a fairly large residual. But when you and Katie and people who get to go this way, you do this on your surface. What's R going to be? Negative slope, perfect regression. Show the least squares line. But now when I add another point that's not on the line, it's going to bring the correlation coefficient down. What's going to happen to the value of little r if I add a point here? Is little r going to increase or decrease if I add a point right here?
Decrease.
I'm sorry? Did you say increase or decrease? Decrease. It'll actually increase. It will increase toward 0. Its absolute value will decrease. And I think that's what you were thinking. Its absolute value decreases, but R actually changes from negative 0.9 to almost 0. So much influence. And that's, I'm just going to put this point on top of that one, so it's almost like erasing it. But if you show the X bar line, yeah, so this point over here has huge leverage, so it's going to have a lot of vertical pull. Really influences the slope. But that's the other thing to look at, is what is the effect going to be on little r when I add a point way up here? What's going to happen to little r when I add this point? It doesn't have much leverage, but it does mess up the association. It goes off pattern. Whereas down here, it really gets it closer to -1. So closer to 0, closer to -1. So let this software operate in your mind so you can get a feel for how these scatter plots work. Question, Katie?
How do you know if a point has higher or low leverage?
Leverage is defined by the horizontal distance from the point to X bar, the X bar line. So,
isn't that like bias though?
isn't that what? I'm sorry.
You know, like bias, like, couldn't you like where's the line where you would define it between high and low leverage?
Oh, right, so there's low, I mean, it's not biased, but it's relative to all the other leverages. Like, this is like the highest leverage of all the points, all the other points. So this is like the standard for high leverage. So in some scatter plots that are like this, and for those of you listening at home, the question was, is this really biased? Or, which I interpret as a question of, is it relative? Okay, so now the line of best fit, all the points have fairly, I mean, this is the biggest leverage point. So now this point would be considered high leverage because it's higher than all the other ones, whereas on another scatter plot that's more spread out, it would be considered, relativistically speaking, low leverage. So just categorize the size of the leverage based on the other leverages. Does that make sense? Further questions on the software? Okay, back to the practice test. So what other questions would you like to ask about the practice test? And we're going for a full understanding on this chat. Go ahead. All right, take a look at problem 4 on the practice test. Oh, yeah. This is the when in doubt, draw it out problem. So if you didn't already, boy, you can learn so much by drawing out these problems. We know that x bar comma y bar is going to be on the line of best fit. So plot the point 10 comma 20. And we also know that r is 0.85. That tells us something about the slope of the line of best fit. Because r is 0.85, will the slope of the line of best fit be positive or negative? It will be a positive slope. So draw a line of best fit with positive slope that passes through the point 10 comma 20. Now, we have to locate x is 15. Okay, so when x is 15, that means we're above average on x, which means we're going to be above average on y. So now you can tell that whatever y hat is, in fact, if they said, what's true about the value of y, the actual value of y when x is 15, the answer would be cannot be determined. We don't know what y is going to be. All we know is the predicted value of y. And so the predicted value of y, whatever it is, it'll be greater than 20. And that's how we know that letter A is the answer. Chad, does that help?
Yes.
Yeah, so when in doubt, draw it out. The diagram will speak to you. Further questions on the practice test? Yeah, go ahead, Sam.
Number 8.
Looking at number 8. Okay, this is the old sum of the residuals of 0. Back to the software. Notice how it's impossible to ever get all positive residuals. The residuals always add to 0. So, I mean, suppose I show the line of best fit and show the least squares line and show the residuals. Notice how some of the residuals are positive, some of them are negative. They always add to 0. So what if I tried to move it? It's like, okay, I want all the residuals to be positive. No matter what you do, it's impossible to get all the residuals to be positive. So that's how we know, just at a glance, that letter C is impossible. You would never have all the residuals being positive. Further questions on the practice test?
But for D, the residual plot is thickening, right?
Yeah, you got a lot of negative, a lot of positive. It shows a pattern. So it is a least squares regression line. We shouldn't, would it be appropriate to make predictions using this least squares regression line? No, but this is an actual regression. You could. It is possible to get this residual plot, which if I could not be a residual plot resulting from a least squares regression of a set of data points. You can do a least squares regression, whether the straight enough condition is satisfied or not. You can do it, and you can get a residual plot. That's a different question. If they had asked the question, which of these residual plots corresponds to a relationship between x and y where a linear model would be appropriate, I would say letter A. Yeah, linear, because this shows no pattern. This shows a pattern. That shows here, does the plot thicken? Yeah, it gets thicker. Here, this is impossible. So then I'd say part A, but part C is the answer to the question that they've put down. Further questions on the practice test? Yes, go ahead.
Can you do 9A?
Yep, let's take a look at 9A. Now, notice the slope is negative. That's why I have to take the negative square root. And then it's a matter of interpreting it. Now, I pushed the top shelf interpretation pretty hard because that shows the most understanding, but you could do this bottom shelf interpretation. But since you're asking about 9A, are you asking about the numeric part or the verbal part? Okay, so the verbal part. So the correlation coefficient, I'm citing it. This means that if the scatter plot is, they didn't show us the scatter plot, so I have to make this conditional. If the scatter plot is straight enough, then what do we have here? We have moderate, kind of in the middle. Is in the middle between 0 and 1, or between -1 and 0. So that's why I'm calling it moderate negative association between these two variables. And I'm just kind of summing it up. Essentially what this means, this is like saying it again, but in more condensed form. Bottom line is that the more you drive your 2006 Subaru, the lower you're going to be able to ask for it. It's getting all used up. You can't ask much for it when you sell it. So that would be a full credit interpretation. It's nice to have this last sentence, but If you wanna really be precise and go for an E+, where you actually include the .6877, then this is something we spend a lot of time talking about, in terms of how to do a top shelf interpretation of R. So it'd be like one or the other, you don't have to get both, you could, but in a multiple choice situation, you never know whether the multiple choice options will be bottom shelf interpretations or top shelf interpretations. So you gotta be ready for both. So do you feel better about that now? Okay, further questions on the practice test? So it's interesting that no one's asking about problem 11. I guess maybe that's because it was like that in the homework and that's fresh in your mind, so you're good to go with those sorts of things. I wonder what would happen if I hope I didn't erase, oh, I erased all the hats. I erased the hats. Didn't want to do that. So what I'm gonna do is close it without saving the free practice test. Yeah, I guess I can find out if I did it right by opening recent and see if my hats have been permanently erased. Honestly, I'm just kind of nervous right now when I think about, oh, they're back. The hats are back. Huh. Now it's time for the GFA activity. So go ahead and clear your desk of everything except for a calculator. We're going to do a GFA quiz, and this is going to go down as either 8, 9, or 10 points in the grade book in the quiz category. Here we go. So team up. Team up. You guys together. Okay, so fold one, your answer sheet. Take it. Fold it. Here we go. These are going to be 3 rapid-fire GFA quiz problems. For those of you playing at home, if you're playing in the luxury and comfort of your own home, just take out a sheet of paper, fold it in half, that'll be your answer sheet. And get someone to play the role of Mr. Royce. Here we go. GFA problem number 1. Here we go. This is kind of a big deal. GFA problem 1. We have a linear regression. It's a scatter plot that satisfies a straight enough condition. X bar is 25. Y bar is 41. R is negative 0.856. And when X equals 35, Y hat is A, or in fact, actually, I'm not even going to say Y hat is. Which of the following is true? A, Y hat is greater than 41. B, Y hat equals 41. C, Y hat is less than 41. D, cannot be determined. Write down either A, B, C, or D on your answer sheet. Determined. If X is 35, I recommend drawing it out. When in doubt, draw it out. Write down either A, B, C, or D on your answer sheet. So what, you have to lift the paper. If you say GFA, that gets my attention, but it doesn't count until the paper is lifted. Lift the paper. See? Okay, so time's up on this one. And hopefully everyone participated. You guys got it? Answer sheet. Okay, so here we go. When you draw this one out, the strategy I recommend is to set up an x-axis with x bar is 25, y bar is 41. Since the correlation coefficient is negative, you know the line of best fit looks like this. X is 35 is greater. So if you're above average on X, you're going to be below average. The answer was C. So one person from each group, come and get your GFA sheet. Now the answer is C. Y hat. So one person from each group, come and get your sheet now. Okay, so congratulations on that. Next one is a calculator problem. And this calculator problem requires that you do following. And, by the way, where's my stylus? Swipe the stylus. Okay. Does anyone see the gray Promethean board stylus around?
$300. Yeah.
All right, yeah, it's only 300. Oh, no, that's not it. So. Oh, wait, I think I found it. Here we go. Next, number 2. So, natural log height, H-E-I-G-H-T, natural log height hat equals 3 minus 2.5, not ln, but log of time. So, I want you to use your calculator to find the predicted height rounded to 3 decimal places when time equals 6. Use your calculator, find the predicted height when time is 6. So the bell's gonna ring, so just do this problem before you go and show it to me on your calculator. So show it to me before you leave the room. Write it down on the sheet and then get everyone to sign off on it.
就是溢出了1.094621874，你写一下你写2.871吗？
Okay, show me your calculator.
耶，很久没有上过课了。你不底下站着。说真的，Sam，你刚才不是别的小学？
All right, so the answer is right there.
里面最伤心的是谢欣宇。
See. There it is, right there. So hopefully you got that on your calculator. I think, yeah. That one's a little hard to read. Here, this one will be easier to read. Answer is this one right there. Hopefully that's in focus. Okay, have a good night.